Okay, for dilute solutions, the osmotic pressure is directly proportional to the molarity of the solution at a constant temperature. It can be given pi, that is osmotic pressure is equal to mRT, where pi is osmotic pressure, R is universal gas constant, M is molarity of the solution, T is the temperature. As we know, molarity is equal to what? Number of moles of solute divided by volume of the solution in liter. This we can put in the osmotic pressure formula. M is equal to N2, number of moles of solute by volume. Okay, I am going to put this in the pi formula. Pi will be equal to N2 by V into RT. Okay, now what is N2? N2 is nothing but given weight divided by molecular weight. Again, I am going to put W by M2 in this equation. So, pi will be equal to W2 by M2 V into RT. Or we can write it down W2 RT into divided by M2 V. That is the osmotic pressure formula. From this formula, we can write down the formula for M2. M2 will be equal to what? W2 RT by pi V. Okay, now what is M2 here? M2 is the molecular weight of non-volatile solute particle, right? So if we perform this experiment, find out the osmotic pressure, we can find out the molecular weight of unknown solute, unknown non-volatile solute very easily. Yes, you can see W2 is mass of the solute, M2 is its molecular mass, R is the universal gas constant, T is the temperature, pi is osmotic pressure, and V is the volume of the solution in liters. Okay, now on the basis of this osmotic pressure, if I am talking about or I am comparing the two solutions, two different solutions, if both these solutions have same osmotic pressure at a fixed temperature, constant temperature, so these two solutions will be called as isotonic. Iso, same, tonic, that is osmotic pressure. Okay, now in this case, if out of the two solutions, like one solution is A, another solution is B, if osmotic pressure of A, pi A, is greater than pi B, right? Okay, so in this case, A will be called as hypertonic. Okay, in this case, A will be called as hypertonic and B will be called as hypotonic solution. Hypo stands for greater, hypo stands for lower. Okay, now you can see here, this is the solution and this is the solvent, and semi-permeable membrane is there in between these two. Okay, so obviously in this case there will be osmosis unless and until the equilibrium is reached. So what will happen? The solvent particles will travel from the low solute concentration to the high solute concentration. Now, just like I have told you, solutions having lower osmotic pressure than another, you can compare it with anyone, is hypotonic, and solution having higher osmotic pressure than another will be called as the hypertonic solution.